Let's give number 25 a try. We're going to solve this by completing the square. Now actually, if we added 12 to each side, I could use a 6 and a 2 and get that 8. So this is going to factor. But let's try this by completing the square. So by completing the square, we're thinking, okay, what do we put here? All right, so we know what we do. We square the first. So what do you square to get x squared? You square x. Then you multiply these two together and you double it. So you're doubling something and you're getting -8. So just take half of this. Half of -8, -4. But now you keep going, and if you keep going, you square the last. So you're really adding a 16 over here. So if I add 16 to the left side, I need to add it to the right side. So I'm going to get that -12. Let me write the -12 here. I'll get the -12 plus 16. Right, what I had to begin with was just this and the -12, but then when I did this, I added, right, square this, I added 16, so I need to add that 16 over here. So, let's see, that'll give us x minus 4 squared equals, -12 and 16 is a 4. Let's take square roots. Square root of the quantity x minus 4 squared equals square root of 4. On the left side, we get the absolute value of x minus 4 equals, well, square root of 4 is 2. Let's remove the absolute value sign, so now we get plus or minus. So we'll get x minus 4 is plus or minus 2. Let's add 4, right? Add that 4 to both sides, so we'll get x equals 4 plus or minus 2. And then what we're really looking at here is this. We're looking at 4 minus 2, 4 plus 2. That's what our x is. So we're going to get x equals, from the first one, we'll get a 2, and from the second one, we'll get a 6. So our solutions, if we write them in a solution set, will be 2 and 6. And sure enough, you can see, if you look back here, that 12 would have factored into the 2 and 6, giving us that 8, right? That 12 gives us to 2 and 6, giving us back up here to 8. Okay, let's give this one a try in 55. Now, in order to do this, we need the right form here, so why don't we multiply these out? So first and the first will give us x squared. The outer product is -x, the inner product is -5x. So -x minus 5x minus 6x, and then the last and the last, -5 times -1 is plus 5. That's equal to 7. Now, you could try to factor this, right? What we could do is, I see I've got it quadratic. I could get everything on one side, 0 on the other. So if I subtract 7 from both sides, it's going to look like this. X squared minus 6x, and then 5 minus 7 is -2 equals 0. But this doesn't factor. The only way I can get a 2 is a 2 and a 1. I can't get a 6 out of that. So it's not going to factor. So let's use completing the square. And to do that, we're going to get the variables on one side and that constant over here on the other side. So let's add 2. We'll get x squared minus 6x, I like to leave it blank, equals 2. Now, what I'm going to do here is factor this side like this. Something squared. And that something will be an x, right? Because we know how to do this. You square the first. What do you square to get x squared? You square x. Then you multiply these two together. So what do I put here? Multiply these two together and double it. So when I double something, I get -6. So what I'm doubling is -3, right? Every time, you just take half of that number. But now, actually now, if I keep going, I square the last. So what I'm really doing here is I'm adding a 9 over here, right? Here's the square the first, x squared. -3x double is -6x, but if you keep going, you're really getting a 9, and there is no 9. So I'm adding in a 9, so I have to add that 9 over here on the right side too. So this is going to be 2 plus 9. So this gives us x minus 3 equals 11, x minus 3 squared. Let's take square roots. We'll get square root of the quantity x minus 3 squared equals square root of 11. On the left side, we get the absolute value of x minus 3 equals, we can't do anything with that 11, so we're stuck with that in a sense. Let's take the absolute values off. I'll do it up here at the top. We'll get x minus 3 equals plus or minus square root of 11. Right? Remember from here, when you remove the absolute values, that's when you get plus or minus, not before. And I think one more step will do it. Let's just add this 3 to both sides. So we'll get x equals 3 plus or minus square root of 11. And if we write, so we get two solutions here, right? We get the x minus square root. I'm sorry, we get the 3 minus the square root, 3 plus square root. And if I write it in our set notation, here's what we get. We get 3 minus square root of 11, 3 plus square root of 11.